All right, so for today's topic discussion, we're going to be discussing the concept of base in mathematics. What is a number base? Why would we ever want to have different bases? And why do we actually have different bases? So first of all, what is a base? Well, a base is you decide for some value that that's going to be the one you repeat as your numbers get larger and larger. So for example, we're in base 10, probably because we have 10 fingers, if I call thumbs fingers. But what does that mean? Well, what it means is that when I write out something, if I write out something like 2, that's a 2, yeah. If I write out 2, 3, 6, then what's going on is that this is in the ones place, this is in the tens place, and this is in the hundreds place. And if I went on, it'd be the thousands and the 10,000s and so on. And you all are probably rolling your eyes at this point and going, yeah, I know. But here's the thing. 1 is really 10 to the 0. 10 is really 10 to the 1, 100 is really 10 squared, and so on. So we've just got a number raised to successive powers here, which is pretty interesting. Well, what it really means to be in base 10 has two parts. It has the fact that each position is a power of that number that I said, which is 10. It also means that's how many symbols we get. So if you look at it, we've only got 10 symbols. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are our symbols. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 symbols because I'm counting 0, right? What's kind of interesting too is actually we don't have a symbol for 10. What do? We write 1, 0 because we don't actually have the symbol for that value. It's almost cheating a little bit, isn't it? We could perhaps have something like an x, right? Because that's like the Roman 10. So then this would be x to the 0, x to the 1, and x to the 2. And wherever I wanted to represent 10, I would just write 1, 0 because those are our allowed symbols. This one was not allowed in our system. Now, once you understand this, once you realize that we're using base 10 and that's just what we use, and that's the pattern, couldn't I use any numbers here? Couldn't I use any symbols here? Isn't it totally arbitrary what my base is? Like what if we didn't have 10 fingers, right? Yeah, we can use different values. Say if I had something in base 4. So say if I wrote, let's say 2, 1, 0 in base 4. Well, base 4 would mean that the only symbols we'd be allowed would be 0, 1, 2, and 3. Notice I was careful not to use something I'm not allowed in base 4 here. And it would mean that each position was no longer a power of 10, but a power of 4. So the first place would be 4 to the 0, which is 1. This place would be 4 to the 1, which is 4. And this place would be 4 to the 2, which is 16, or 4 squared. And notice I mentioned that here we don't actually have a unique symbol for 10. We're kind of cheating. We're doing the same thing here in base 4. We don't have that symbol. That's not permitted. And so we're kind of cheating. We're writing 4 to the 0, 4 to the 1, 4 squared. And that's going to happen with all these bases. It's kind of interesting. And so this number here is not the same thing as it would be in base 10. It doesn't mean 210. It means 2 lots of 4 squared, right, plus 1 lot of 4, plus 0 lots of 1, because 4 to the 0 is 1. And so we have 2 times 16 in base 10, plus 4, 1 times 4, and that's 32 plus 4, which is 36. So in base 4, this number actually represents the value 36 in base 10, which is pretty cool. Now, you could have larger bases, right? So I mentioned here that we could have had a symbol for 10, we could have used x. Well, what actually happens is say you do something like hexadecimal. That goes all the way up to 15 as far as symbols, and what it is base 16. And so you would have all these symbols, 0 through 9, and then you would go 10, 11, 12, 13, 14, 15. And so then, say you had something like E1B. And this is in hexadecimal, which is base 16. So that means that each of these spots are now powers of 16. This one would be 16 to the 0, which is still 1. And again, once again, I am cheating. We don't have a symbol for 16, so I'm just writing it however I can so I recognize it. 16 to the 1, 16 squared. So I'm not going to multiply this number out because I don't have 16 squared memorized in my head. I'm actually pretty bad at multiplication, but it doesn't matter as long as I understand the idea here, right? Because the idea is that this is the value 11. So I will write out the expansion here. This would actually be E, which is 14, right? 10, 11, 12, 13, 14. So this is 14 times 16 squared. 1 is still just 1 times 16 to the 1. And B is, well, 10, 11. That's 11 times 16 to the 0, which is still just 1. And then you could throw that in and you'd work it out, whatever it is in base 10. So you can have any number system you want. It can be any base you want. And it's totally arbitrary. And what's interesting is historically, there are different bases. The Mayans use some sort of weird mixed base where it goes like, I think it's 18 by 20, and then they go on from there. The Babylonian number system is base 60, right? So you've got powers of 60, so you can write really big numbers really quickly, and so on and so forth. And of course, I can't finish this topic without pointing out that binary numbers are a thing, right? So if you're in base 2, your only choices are 0 and 1. Those are your two symbols, nothing else. So then I just have to have more slots. So each position would be a power of 2. So the first slot would be 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, etc. And so if I had something like 1, 0, 1, 0 in base 2, that is not 1010. It's 1 by 2 to the 3rd plus no, or 0, by 2 squared plus 1 by 2 to the 1 plus 0 by 2 to the 0, which would be 8 in base 10 plus 2, which would actually be 10. So that would be 10 in binary. So hopefully this gives you an idea. It's sort of an overview of some different number bases, some that have fewer symbols like base 4 and base 2 or binary, and one that has more symbols like hexadecimal or base 10. And you can see that this is totally arbitrary. You just have a set amount of symbols, right? And in this case, we even started using A, B, C, D, E, F to go past the value 9. You just have some arbitrary set of symbols. You put them in positions, you raise them to certain powers, and then you just list how many of each of these spots you have. So one final comment, you could be totally weird. You could have lots of fun with this. I could say that my symbols are triangle, square, smiley face, and, I don't know, a fish. And as long as I know what these values are, and they don't even have to be in order, this could be like, this is going to be an amount of 3, this is going to be an amount of 7, this is going to be an amount of 2, and this is going to be an amount of 11. Oh, I did all primes. It doesn't even matter what your symbols are. I could just be like, okay, cool, this is going to be triangle, smiley face, and fish. And let's say these symbols are in, well, I've got 4 symbols, so let's call it base 4 again. So this would be base 4. So then each spot would be 4 to the 0, 4 to the 1, 4 squared. And so this value right here would be triangle, so 3 times 4 squared, plus smiley face, so 2 times 4, plus fish, which is 11 times 4 to the 0. And so on my I just made this up on the spot, in my totally random number system here, this would be 3 by 16 in base 10, plus 2 by 4, which is 8, plus 11 by 4 to 0, which is 11. 3 by 16, that is 30 plus 18, so 48. Plus, if I add those, I get 19. And so that's going to be 67. So I totally just made up this system on the spot. I just like triangle, square, smiley face, fish. I got 4 symbols, so it's base 4. And then I just threw everything in the same pattern and I got out a value 67. Now, of course, I made this up. You might not be able to represent all numbers this way, and maybe it has some conflicts. I don't know, but I was able to write something down and get a number out of it. So that's the idea. Perhaps you'll be walking around looking at base 10 and just be like, whoa, it doesn't have to be this way. I don't have to have this many fingers to do math. Whoa. So hopefully that's kind of opened your mind a bit to what math is. It's really more about symbols than anything else. And that's this discussion on different number bases, what it is, and how awesome it is.